All right, so let's do 4O number 10. So the base of a solid is the area bounded by these two functions. So y squared plus 2, so there's 2, and x equal 4. So this is the bottom of the solid. So this a three-dimensional thing popping out of the page. Cross sections perpendicular to the y-axis means this way. Means you have to do dy integration, which we kind of want to, because otherwise we'd have the same function top and bottom. So what's the shape? The shape is a semicircle. So that's 1/2 pi r squared. So this distance here is the diameter, right? This is the diameter. Okay, so let's figure out what the diameter is, and then we can figure out what the radius is. Okay, so when we're measuring things from here, we go all the way out to here, which is 4, right? So I'm figuring out what the diameter is, go all the way out to 4, and take away this distance. So subtract off y squared plus 2. So this gives me 4 minus y squared minus 2. So this gives me 2 minus y squared. So that's the diameter. So let me just write it down here so you can see it clearly. So the diameter is 2 minus y squared. So the radius is going to be half of that. So I'm just going to take it and divide it by 2. All right. So that means, I like to go slow, 1/2 pi radius 2 minus y squared over 2 all squared. That's what I put in my integral. So the volume is the integral of the areas, adding up lots of areas. So 1/2 pi 2 minus y squared over 2 squared dy, and I need to say where on the y-axis I'm starting and ending building these semicircles. So where do these two things run into each other? So y squared plus 2, y squared plus 2 equal 4, so y squared is equal to 2. So negative root 2 and root 2. So I'm noticing on my answer I forgot the 1/2 pi. So this is a great question. I'm glad someone asked this. All right, so let's go to number 16, that same assignment, 4O, number 16. So 3 to e squared. Oh, look at this ugly thing. Okay, so for sure a u substitution has to come to the rescue to help me do this. And let me even just split this up so I can see what I've got. So I've got 1 over x, 1 over the square root of ln of x, and a dx. I know something about ln. ln is an inside function, so I'm going to let that be u. So my derivative is 1 over x dx. Oh, there it is, 1 over x dx, right? Okay, so let's do it. So I get 1 over x dx gets taken out and du gets put in. I'm going to put the u inside here, so I get 1 over the square root of u. And then I'm going to change my limits. So I'm going to put 3 in for x, so this gives me ln of 3. I'm going to put e squared in for x, and I'm going to get 2, right? Because you know that ln of e squared is the same thing as saying 2 times ln of e, and that's 2. All right, so now I'm going to rewrite this so I can take the antiderivative. ln of 3 to 2. So I add 1 to the exponent, put it over that same number. So I'm going to carry the 2 on the outside. I like to put the 2 on the outside like this, then go plug in the top number. So square root of 2, subtract off the bottom number, the square root of ln of 3. And that's a great answer, just like that.